Hello, students. We've been kind of going back and forth with Bohr models and Lewis dots and ions, and it's starting to become kind of clear that about half of us struggle at various points in this process of building a Bohr model or making a Lewis dot diagram. So I want to give you a quick tutorial so that you can watch it on your own at home and review it as many times as you need, because I really need you to master this concept so that we can move on. I don't want to drag this out any longer because it can't, let's face it, if we keep going over the same thing over and over, it'll get kind of boring. So let's master this so we can move on and we can go on to bigger and better things. All right, here it goes. We are going to try to build a Bohr model for the element known as lithium. There it is in the upper left-hand corner. You see the atomic number, you see the atomic mass, and then over on the right-hand side, I'm showing you the two stable isotopes of lithium. There's lithium-6 and lithium-7. We're going to have to choose one of those in a moment. But first, let's do the easy part. Remember, when you're trying to figure out how to go ahead and build a Bohr model, you got to first build your nucleus. And the atomic number right away gives us useful information. It tells us that there are 3 protons in that nucleus. That is a very direct connection. So the atomic number is exactly the number of protons. But then where do you go from there? Well, here's where I have to tell you which mass number we are dealing with, which isotope of lithium we are dealing with. So we're going to imagine we're dealing with the more common one, which is lithium-7. Okay, with that number, with that mass number, it tells you, now listen carefully, because this is the part that a lot of you are struggling with. The mass number of an element tells you how many particles are in the nucleus. There's actually a word we use for things in the nucleus. It's a word I haven't used in class yet, and the word is nucleons. Believe it or not, a nucleon is a particle that exists in the nucleus of an atom. Well, we know that there are 7 nucleons in lithium, but we already know that 3 of them are protons. So how many do we need to throw in there? How many more nucleons do we need to make it 7? Well, 4, right? So that tells us that there are 4 neutrons in this nucleus. And you need to make sure, if that's a little confusing for you, pause it, rewind it, rewatch it, okay? Because the number of protons that you have added to the number of neutrons that you have has to always equal the mass number that we are dealing with. Always. That's how you figure out the number of neutrons. Okay, so then you got to go on and you got to figure out your electrons. And again, that's where you get to go back to the atomic number. The atomic number is very useful when you're building a Bohr model because it tells us that just like we add 3 protons, well, we also have 3 electrons. Okay? And if we remember our rules, we know that there can only be how many in the first shell of an atom? The answer is 2. Okay, so we only have 2 electrons in the first shell. That's all that can fit on the first shell. Well, we need to put a third electron here. So that means that we need to go out to the next energy level, the next electron cloud. And so we're going to put that third one out there. Great. We're pretty much done with our Bohr model at this point. But now we have to move on to the Lewis dot diagram. And we can use the Bohr model to springboard to that. Because remember, folks, a Lewis dot diagram is concerned only with your valence electrons. That is it. And again, remember what a valence electron is. By definition, it is an electron that is on the outermost energy level or electron shell of an atom. There could be more than one, but in this case, there's only one. And it's on that second shell. And the second shell is the outermost shell for lithium. So lithium has 1 valence electron. And so now we take a look down lower, and I'm starting to build the Lewis dot diagram for you. You start off by writing the chemical symbol for the element. In this case, it's Li. And then I misspoke yesterday. I think I told you to start on the top, and I don't know what I was thinking. You start on the right. Okay, so you place a dot, And in this case, we only need one dot because lithium only has one valence electron. So you're done with the Lewis dot. It's that easy, okay? If you can demonstrate those skills on a quiz, you're gonna do really well, okay? And I need you to get there very quickly. Okay, let's do one more, quick one. I'm gonna go over to fluorine, okay? So now we have fluorine, which has atomic number 9. You see that up here, right? There's its atomic mass. We don't really deal with that too much in this course. Isotopes of fluorine, there are a lot. I think there's something like 17 isotopes, but fluorine 19 is the only stable one. When I say that, I mean if you have any other isotopes of fluorine, the atom, the nucleus breaks down and loses particles very quickly. So we're not really going to worry too much about those because they just don't stick around very long. But fluorine 19 is stable. So when the universe creates an atom of fluorine 19, it sticks around. Okay, let's go ahead and build that Bohr model. First step, what are we going to do? We're going to look at that atomic number, and that's going to communicate to us the number of protons, 9. Remember, it's a direct connection. If the atomic number is 9, your number of protons is 9. And then you have to figure out the number of neutrons. What do? You consider the mass number. The mass number that we are dealing with is fluorine 19, right? So what plus 9 equals 19? Because remember, 19 tells us that there must be 19 nucleons in this nucleus. And we already know that 9 of those nucleons are protons, so we know we must need 10 neutrons to bring it up to 19 nucleons. Awesome. Hope you get that. This is the point where you want to learn it for good, make it concrete so you never even have to think about it on a quiz. This should be an easy A for you, right? Help me give you an A by reviewing this material because I want to give you an A. Okay, now we're going to go on to those electrons. We go back to that atomic number. We know we have 9 electrons. Great. But we know we can only put 2 of them on that first energy level. So we know we're going to have to go to that second energy level. And that's where we're going to put the remaining 7, because how many can you fit on that second energy level? The answer is 8. You can fit up to 8. Well, we don't need 8. We only needed room for 7. And so we're going to throw all 7 on that second shell. Great. So there are 9 total electrons, but how many valence electrons? How many valence electrons does fluorine have? Well, count them. 1, 2, 3, 4, 5, 6, 7. So let's go ahead and build that Lewis dot diagram, starting from the right and moving counterclockwise. 1, 2, 3, 4, 5, 6, 7. Voila, you are done. You have the Bohr model complete, and you've made your Lewis dot diagram, and life is good, and you get yourself an A. So you can guess what I'm going to do to you now. And I'd like you to make sure you have a periodic table and a blank piece of paper, because here's what I want you to do. I want you to go ahead, and I want you to construct a Bohr model and then a Lewis dot for sodium-23. Okay, the isotope of sodium, known as sodium-23. Here is the information over here in the upper left that you also need. Okay, that's what you would see on the periodic table. And then when you're done with that, I'm going to want you to do this one here. Chlorine-35, the isotope known as chlorine-35. And there's the information over there. So, have at it. Oh, and by the way, I should say, you'll notice in these 2 slides, I probably shouldn't have done this, but I threw in all 4 electron energy levels. I shouldn't have done that because you might think that you need 4, and remember, you only need to put in the number of electron shells that you need to accommodate the electrons that you have. Okay, I'll give you a hint. For sodium, you're not going to need that outer one that I've shown there, that 4th energy level. It's not even necessary. All right. Good luck.